Hello everyone, welcome back to my YouTube channel, Physics Fundamentals with Thomas Adeoye. Today we are going to be doing a very important task, which is together we are going to be solving JUPEB Physics past questions. And it might interest you to know that the solutions are going to be exam focused. And because of that, some points I may not overstretch. Thank you as you journey with us. To begin with, we are going to solve this question. A boy walks 10 meters due west and 10 meters due south. His displacement is what? Okay, so one of the things I want you to understand in physics is that whenever you see a problem, try to identify where the problem is coming from. Yes, this is a good thing. Try to understand where is the question coming from. So under what topic in physics is this question? So this question is from addition of vectors. You may want to check some of our videos on addition of vectors on the same YouTube channel. Okay, so now that we have identified where the question is coming from, which is under vector addition. Okay, so mind you, do not forget that in the question we are to calculate this thing, we are to calculate displacements, and displacement is a vector quantity. Okay, and do not forget is under addition of vectors. So the first thing I would love to say is that in this kind of question, we have a boy. The boy walks 10 meters due west. This you can represent using a line segment with an arrowhead, and the arrow indicates the direction. Okay, so and the second thing that the boy did was that he continued the journey, and now he walked 10 meters due south. This also you can represent with an arrowhead. Now for the first part of the journey, let us use this. Okay, I'm sorry, I should mention this. So on a cardinal point, this is the north, this is the, yes, this should be east, and this is south, and this is west on the cardinal point. So we have this is west. Okay, now the guy, do not forget, walked 10 meters due west. So this we can represent using we can use a straight line. We did vector representation in one of our videos, so if you want to check that, so you can represent a vector with a straight line like this. So the length or how long the line is, so indicates or determines the magnitude. What is the magnitude here? 10. So if the magnitude is 10, then we can assume that okay, this is 10. Okay, so that is if a line is as long as this, we claim that it is 10. So if we want to represent another vector now with magnitude 12, you guessed right, it should be longer. The magnitude is 4. If we claim that this is 10, I mean what we just was gonna drill is 10, then if it is 4, of course it has to be shorter. Okay, we are the one determining the scale, we have the power. So now what I drew now, I assume that this is 10 meters long. It's not drawn to scale. Okay, so with an arrow, if it is a vector, there has to be an arrow. So the arrow will determine the direction. Okay, and if you look at the cardinal points, as you can see, this indicates west, this is east, this is north, this is south. So if something is west, is directed westward, of course it should be like this. So because of that, it means the arrow should be facing this direction. So because of that, our vector, which is 10 meter due west, something like this. So this is how the arrow faces. Okay, now the next thing is to move on to 10 meter due south. For 10 meter due south, this is what you can do. Yes, you draw another vector. This is 10 meter. Let me write 10 meter west. Okay, and we have another vector like this, and they have to be of the same length. You know, the length indicates the magnitude of the vector, and the arrow, which is facing downward now, due to the fact that now this one is south, is 10 meter. We have to be 10 meter south. Okay, so this is a vector which represents 10 meter. This vector represents 10 meter southward. Okay, and this is the arrow, this is the length, and this is the tail. Okay, this is the tail of this vector as well. Now in vector addition, so if you have not watched our videos on vector addition, you are still fine. Just take it this way. If you have two vectors like this and this, and you want to find the displacement, in other words, I can say if you want to find the resultant, okay, then all you need to do is to, one of the ways of adding vectors, yes, together is using tail to tail method, which I'm going to use now. And what is tail to tail method all about? It means you are going to merge the tail, or you place the tail of one vector with the tail of the other. Is that taking? You place the tail of one vector with the tail of the other. So now this is a vector 10 meter due west. This is another vector 10 meter due south. What I did was that I tried to represent this question using using a directed line segment and an arrowhead. Okay, so and in order to add this and this together is the addition that will give me the displacement. So I can use tail to tail method, and in doing that, all I need to do is to place the tail of this to the tail of this. Okay, and if I do that, I'm going to have something like this coming. Let's draw a diagram here. So this is the first vector 10 meter due west, and this is another vector, this 10 meter south. Now the tail of the first one has been placed on the tail of the second one, and now we have this. So we have 10, we have 10. Okay, and moving on, now that we have this diagram, another thing you need to know about tail to tail method, you know, I told you if you want to add vectors together, you can use tail to tail method by placing the tail of one vector with the tail of the other. Okay, you want to add two vectors together. Now that we are done placing them together, then the resultant, which is the sum, the vector sum, the resultant represents the displacement in this question. So the resultant will now be a straight line that is drawn from the point of intersection of the from the point of intersection of the two vectors. So from the point where the two tails are placed together, then the resultant will come from them like this, and with that, it means the resultant will be a straight line that is drawn from here. Then this is the resultant. Okay, and if you look at it, let's use R to represent the resultant. Okay, and mind you, in this situation, the resultant it represents the displacement. So this resultant now, you can see the resultant. So I can complete the triangle so that when I have this, yes, this line, let me use my lighter, my laser. So this line and this line, they are equal. Don't mind the drawing. So this one is a projection of this. So, and since this is 10, so it means this guy is also 10 like that. So we have 10 meter. So, and we're almost there. So now, this is a right-angled triangle. Yes, it's a right-angled triangle, and this is the hypotenuse side. So in order to find the hypotenuse side, so I'm sorry, we are going to go back to our trigonometric, and we know that we are going to be using Pythagoras theorem. Okay, so let's borrow the math, and the formula is going to be something like this. That would be r squared, which is the hypotenuse squared, will be equals to adjacent, which is 10 squared, plus opposite squared. We have another 10 squared. Okay, and if you do the math well, you are going to get 100 plus 100, that will be 200. Now your r, which is now going to be equal to square root of 200. I think that should give you 10 root 2. 10 root 2 if you punch your calculator. So you're now having to be 10 root 2 meter. Now we have found the magnitude of the resultant. What we just calculated, what we just got is 10 root 2. 10 root 2 is just a number, it's just a value. Okay, and if you look at our option, so option A is 10 root 2 meter, and we have something like this. Okay, this is 45 degrees west of south. I'll teach you how to read this. Okay, as we move on, this one is 10 meter, this is 60 degrees rather. This is not south or west. Don't worry, I'll teach you how to read it. It is 60 degrees west of south. Okay, now C, we have 10 meter, 30 degrees west of south, 10 root 2 meter, 60 degrees west of south. Now the bad news, we will not have bad news or receive bad news, is that, but what is not good here, let me put it that way, is that we have 2 10 root 2. The good news is that 10 root 2 is there, but what we don't like now is that we have 2 10 root 2. I mean in option A and option D. So we can eliminate option B and C. So we are left with 2 options, okay, to gamble with, but we are not going to gamble. So we are going to get there. So now, in order to calculate the what now? In order to calculate the, what do I want to say? So now, I forgot to mention, we have gotten 10 root 2. 10 root 2 is just a value. Yes, that was what I was saying before. It's just a value. And because it's a value, it's just magnitude. What we just calculated is magnitude. But we need magnitude and direction because displacement is a vector quantity, and by definition a vector quantity can only be completely described in terms of 2 things. One, its magnitude and direction. So now we need to move on to calculate the direction. But how do we calculate direction? So to calculate direction, now we go back to the diagram. This is the reason why the diagram is very important. We could have just drawn a right angle triangle and just calculate the hypotenuse, then we do the math, and that's just the math. But this is physics. So now direction is very, very important to us. Just like units, they are very, very important to us. Okay, so now because of that, this diagram is going to be very important. I didn't just draw the diagram anyhow. Someone could have just drawn a right angle triangle and calculate the hypotenuse, but I didn't just do that. Why? Because I know if I'm interested in the direction, then if I just draw the triangle anyhow, then I won't get it. So we'll come back to the direction, sorry, to the diagrams. Okay, so from this diagram we can calculate the direction. The direction will be the angle that the resultant, which is the displacement now, makes with either south or this guy. Is that the angle that it makes with this or this? So we can calculate the angle that it makes with the south or the angle that it makes with the west. So if we calculate any of them, then we can know the the direction. Okay, so once we calculate one, easily we can get the other. Okay, both of them will not be in the options, so because both of them will be correct. If I'm interested, it depends on your choice if it is theory, but if it is objective, you have to look at the options to get to know, okay, which one is there, because there are two possible answers like that. You can calculate the angle that it makes with the south, or you calculate the angle that it makes with the west. Okay, so now let's calculate the angle that it makes with the what? With, okay, let's say west, because Nigeria is in West Africa. Okay, so now the angle that it makes with the west, and we have this angle. So what do we call it? We love theta. I'm a lover of theta also. So let's say theta. The angle is theta. Okay. So I'll suggest we use the next slide so as for us to have a clean sheet to work with. Okay. Do not forget that this is what our diagram, what it looks like, something like this. We have west, we have south, and the resultant is like this, and this is the angle we are interested in. So these are angle theta. Okay, so and this guy is 10, this is 10, and yes, so we can try to, here it is 10, here too it will be 10. Okay, so this will be 10 as well. So we have 10 here. Now this is theta. So if you look, if we use the trigonometric rate, the SOHCAHTOA, yes, SOHCAHTOA, where so is opposite. O stands for opposite over hypotenuse. Ka, that will be adjacent over hypotenuse. Toa, we won't talk much on this. This is not a math class. Opposite over adjacent. So now if we use SOHCAHTOA, let's use this is theta, and this is opposite to theta. Theta is sitting on this guy, and this is adjacent. Okay, and so let's use opposite and adjacent, or we use sine like that. That will be so. So we can say that sine theta will be equals to opposite, that is 10 over 10, and sine theta will be equals to, is this so is opposite over, no, opposite over hypotenuse. Now what am I doing? I'm sorry for that. So is opposite over hypotenuse. What I want to use is opposite, this over this. This is adjacent now. Yes, now this is opposite, and no one is online. So this is 10 over 10. That will be opposite over adjacent, and that should be TOA. So this is TOA, opposite, adjacent, and how to rub this guy off. So we can rub this up like this. So sorry for that. So we are going to use where's my pen? Okay, now I found it. So we are going to use TOA, that's tangent. That will be tan theta equals to opposite 10 over adjacent 10. So we have tan theta, let me punch my calculator, equals to 1. So your theta will be equals to arc tan 1, and that should be 45. Yes, so shift, where's my calculator? Shift tan 1, good, that's 35. So it means theta is 45 degrees. Theta is 45 degrees. So this angle is 45 degrees. So if you want to find this angle too, let's call it alpha. If theta is 45 degrees, this theta is 45 degrees, then, and this whole thing is 90, is a right angled triangle. This is a right angle triangle. So then this angle is a right angle. So it's 90. So if theta is 45, this should be 90, the delta minus 45. That should be 45 as well. Okay, so now the next thing I want us to do now is that we already know the angle. Okay, so and yes, we can see that this is west, this is west, and this is south. So a vector that falls here, a vector that falls in between. Now, if you want to represent the vector, or if you want to describe the vector, you can either use west of south or south of west. Okay, so west of south or south of west. Now, but what I want you to know is that the angle you are considering will determine if it is west of south or south of west. Are you with me? So let me take you there. Now, this you may need for some other yes, for some other lessons. So that's why I would love to explain how to represent it. Let's use the next page slide. Okay, so if you have something like this, suppose you have something like this. If you have a vector, here, yes, this vector A, let's call it vector A, and let us assume the vector, this is north, this is east. So if the vector makes angle 30 degree with this, it makes angle 30 degree with the east. Are you with me? So, or we can say that the angle is 30 degree from the east. You know, this is east, and then this is east, and the guy makes angle 30 degree with the east. I mean, the angle is inclined to the east now. So, because the angle is to the east, the angle we are considering is to the east. So, if I want to represent or describe this vector in terms of this, then suppose the vector is 2 Newton, then A will now be 2 Newton, comma 30 degree. That's 30 degree, the angle that is here. So this 30 degree, that's it. 30 degree, then the angle is to this guy. So we are going to say north of east, because the angle is measured from east. Do you get that? It's measured from east. So because of that, we are going to say north of east. You don't say east of north in this. You can, east of north can be correct if the angle we are considering is the one that is from the east of north is correct if the angle we are considering is the one from the north. So we are still going to consider that, okay? But the angle we are considering now is this 30 degree, which is inclined to the east. So it will now be 2 Newton, 30 degree north of east. The angle is of east, or we say it's measured from east, or is inclined to east. Do you get that? So it will now be 30 degree. So we say north. Oh, where's my pen? North. Yeah, north of east. Okay. But another thing I want you to know is that you can also represent it this way. North of east is north of east NE or EN. So if you say EN, you are wrong. Sorry, if you say NE, you are wrong. North of east is not NE. You read it from the back, I mean from behind. Okay, that's crazy, I know, but that's to be from the back. So NE now, this NE, the NE is, it reads east of north. So EN now it reads north of east. So in order to represent this again, I can say 2 Newton, 30 degrees. Some people will not use north of east. Instead, they will just put EN there. Yes, they will just put EN there. And the EN stands for north of east. Is that taken? Okay. Now, suppose the angle I want to consider. You know, I told you can consider any of the angle. It depends on you. But at times, you have to look at the question, and if it is objective, MCQ, you check the options and what is in the option. Okay, now here you can see that if I want to consider the angle that it makes with the north now, the angle that this guy mixed with this. Then since the angle that it mixed with the east is 30, and from north to east 90 degree, so the angle that it makes with this, of course, will be 90 minus 30, and that will be 60 degree. So if that is what I'm using, then this vector A will be 2 Newton. The magnitude does not change. It will now be 60 degree, but the angle is to the north now. It will now be, what's it gonna? East of north. Yes, you got it. It will be east of north. Okay. Now it's east of north. So for east of north, it means I can say it is 60 degree east of north. NE. Yes, NE. So NE. And if I like, I may put it in between. Instead of saying 60 degree NE, I mean the angle, I can put it in between. So this reads 60 degree east of north. Is that taken? So we are going to apply this to our work now. And if you look at it, you are going to see that for what we got, so this is the displacement, and the angle we got is 45 degree. Okay, and so we can now say that our displacement will be equals to, we got 10 root 2 as a magnitude. So we have gotten the magnitude since. What is giving us challenge is the direction, which is very important in vector addition. So it will not be 10 root 2 meter, comma, then the next thing is 45 degree. So this is west. It is no longer east and north. I use that as an example. So west, then here we have south. So now, but the angle is to the west. Do you get it? Because the angle is to the west, so it will be 45 degree. You got it? Do you want to guess? 45 degree is to the west. It's of the west. So you say south of west. And what is south of west? Is it SW or WS? It is WS. Okay? So another thing is, we can consider the angle that it makes with the south. In this case, the angle is still the same. So that means, you know, I told you there are 2 ways you can represent them. Both of them are correct, but one will be in the option if it's MCQ. So it will be 45 degrees again. So now this one is west of south. So because it's west of south, it's SW. And this should be, I told you can put the angle in between. You now have S 45 degree W, and voila, we are done. So maybe like, why did it take so long? I took my time to explain all this, not just because of this question, but because of, if you come across questions like this, questions on addition of vectors, then you can be able to, you know, knock them out and not the other way around. Okay, so let's move on to question 2. So look at this question, the second question. 2 perpendicular forces have a resultant of 13 Newton. If one of the forces is 5 Newton, then the other force is. Now we have 2 perpendicular. Mind you, let me give you the summary of what we did in the first question. The 2 questions, the 2 vectors, they are at right angle. So if we have 2 vectors at right angle, then 2 vectors at right angle, then the resultant of such vector will be the hypotenuse. Just take it. If you have 2 vectors at right angle, then the resultant will be the hypotenuse. So a line that is drawn from the point of inclination. Okay, so now they mention 2 perpendicular forces in this question. Because they are perpendicular forces, you know that you can just draw a right angle triangle. It means we have 2 forces and the angle between them is 90. Okay, so and the resultant of course will be this. We already know that. So now have a resultant. They gave us the resultant. Oh, sorry. They gave us a resultant to be 13 Newton. Okay. They said they have a resultant of 13 Newton, and this is the resultant, 13 Newton, and this makes a complete right angle triangle. If one of the forces is 5 Newton, the other force is what? So it means if one, let's assume this one is a 5, one of them is 5, then the other is x, we don't know. So if this is 5, then this is 5. This question is in a way related to what? Sorry, why did I write x? This should be 5 as well. So it's in a way related to what I solved in the first problem. So we are not going to waste time solving it. Now the question is the other forces. This question is simple actually. We are just to calculate the magnitude. We have perpendicular forces. The forces are perpendicular, they are at right angle. Then the resultant will be the hypotenuse, and the hypotenuse is 13. So one side is 5 Newton. Then we should find the other side, and that's just it. And by using Pythagoras theorem, so we know the resultant, which is 13, will be 13 squared equals to, we can say adjacent, let's take that, s squared plus 5 squared. Now then your x squared will just be equals to 13 squared, which is 169 minus 5 squared, and that should be 25. So if you do it well, I think that should be 144. If I get, yes, 144, then your x, we have to find the x, but this is s squared. X will now be square root of 144, and that will be 12 Newton. So the answer is B. So moving on to the next question. In this question, we have to calculate the dimension of power. Okay, this is on dimensional analysis. So just to remind you, I have a video on dimensional analysis for secondary school students, and also I would say for first year university students. You may want to visit my channel. Now the videos are wonderful. Now the dimension of power. Okay, so power is the rate at which work is being done. So it is the rate at which energy is being dissipated. Okay, and is it dissipated? Let's say it is the rate of change of energy. Let's put it that way. Okay, so now the power can be, you can find the formula. You can say it's energy over time. You can say it's work over time, but for the sake of this, you can use any of them to calculate this actually, but I want to use work over time to know the dimension of power. Okay, so in dimension, any question that has to do with dimension, the first thing you need to know is that you have to understand what is the formula. So if you know the formula, then you are good to go. So that's why I started with the formula. So power is work over time. Now the next thing is work. What is the formula for work? Okay, so you can see how I'm breaking it down. Work is force times distance. Yeah, it can be calculated by the work force times distance. Okay, now divided by time. Okay, so now if you look at this guy, another thing whose formula I may want to find is force. What is force? Force. So I'm asking you, what's force? Force is mass times acceleration. So that will now be mass times acceleration times distance, everything over time. Okay, so now I think we are good to go. Let's just begin to do the needful. So we can now begin to write the units of all of this. Okay, so you can see where I started from. I started from the formulas. Now when I broke it down, then you begin to write the units. So you combine all the units together, then you find the dimension. So what is the unit of mass? The unit of mass is the SI unit of mass is kg multiplied by what's the unit of acceleration. The SI unit of acceleration is meters per second squared, ms raised to power minus 2. So it means acceleration is ms raised to power minus 2, then times, so I will have to rub this guy off, times what is the unit of distance. Distance is measured in meter. Okay, everything over what's the unit of time. Time is measured in seconds, and you can't, let's do this way. Now another thing I want to do is from here now I can try to simplify. We have kg here, this is meter, this is meter, that will be meter squared, meter m raised to power 2. Now this is s raised to power minus 1 divided by s. Okay, so and in indices, if you have a, let's assume you have a squared divided by a raised to power 3. So this is equals to a raised to power 2 minus 3. Do you get that? So you have to, the bases are the same. We have a, the index, the power is the index, is 2 here. For the one at the bottom, the denominator, the power is 2, is 3 rather, but the same basis is still AA. You can just pick one, then the one on top 2 minus the one at the bottom. So here, the power of these seconds, because it's just 1, it's just s, so we can see it's s raised to power 1. Then this will now be s raised to power minus 2. We have it on top. Following the rule here, this rule of indices. So now this is s raised to power minus 2 minus, then what we have at the bottom, 1. For this it is a raised to power 2 minus 3. All right, so now if we do that, then this simplifies to kg m raised to power 2, because we have meter times meter up. Now s raised to power minus 2 minus 1, and that will give you f raised to power minus 3. Now the next thing is the dimension of mass. Kilogram is the unit of mass. The dimension of mass is capital M. The dimension of meter is capital L. The dimension of time is capital T raised to power minus 3, and the answer should be D. Yes. Okay, now let's move on to the next. Okay. In this question, a car traveling at a uniform speed of 100 kilometers per hour spends 15 minutes moving from point A to point B along its route. The distance between A and B is, okay, this is a very cheap question, I won't lie to you. And the formula is just, if you have a problem like this, you should, if you read this problem, you see that a car traveling at a uniform speed of 100 kilometers per hour. So if the speed is uniform, what does it tell you? It means the speed is constant. And if the speed is constant, it means the car is not accelerating. The acceleration is 0. Do you get it now? The acceleration is 0. So for a question like this, then this formula will definitely work, which is simply, let me use this instead. You can just say that the average speed will be equals to distance over time. Yes. So this is just the formula. This is just the formula we are using for this question actually. Okay, and we want to calculate distance. So you have to cross multiply, then distance will be equals to speed times time. So it's just you multiplying speed by time. But what can pose a challenge is that if you look at the units here, the answer is in kilometers. So, and the speed is in kilometers per hour. So the time is in minutes. You have to convert 15 minutes to hour now. So, and if you want to do that, since 60 minutes make 1 hour, so you divide this by 60, and that will give you the time in hour. So now the speed is 100 multiplied by 15 over 60. Okay, so and if you do the needful, I think this should give you 1 over 4. That should be 25. So the answer should be 25 kilometers, and that's option C. Now let's look at this question. Okay, I love this question actually. Okay, now we have two bodies, X and Y. Start from rest. When you read physics question, please read intelligently, because there are usually hidden parameters. There are some things that they will give you. I mean, there are some statements that when they make them, they have meaning, okay, in the world of parameters, okay. Like two bodies which starts from rest now indicate that their initial velocities are 0, okay. They have 0 initial velocity. So start from rest and move with uniform acceleration. Mind you, the last question was uniform speed, and I told you that uniform speed means that the speed is constant, and if the speed is constant, the acceleration is 0, because acceleration is how speed, or we can say how velocity is changing with time. You know, when the velocity changes with time, we say the car is accelerating. Okay, so but if it does not change, if the velocity is not changing, it means the car is not accelerating. So that means the car has 0 acceleration. That is, it has no acceleration. But in this question, they didn't say 0, they didn't say uniform speed. Look at it. The question say it moves with uniform acceleration. So it means in this situation, it is the acceleration that is constant. So we can't say the acceleration is 0. Mind you, uniform speed implies 0 acceleration, but uniform acceleration does not imply 0 acceleration. Okay, so that's the point I'm trying to make. So with uniform acceleration, and they gave us the acceleration to be A for car X. You know, we have 2 cars. Then the acceleration for car Y is 4A. Now, respectively. Okay. Now, if the bodies cover the same distance, you should know that the body covers the same distance in time, not different time. T subscript X for the car X, T subscript Y for the car Y. Then the ratio of Tx to Ty is, we have to find the ratio of Tx to Ty. And in order to do that, we are going to use this formula. The formula, whenever you have question that deals with uniformly accelerated motion, are you with me? Uniformly accelerated motion, that is bodies that are moving with constant acceleration. So now we have equation for them. There, one of them is V equals to U plus AT. Another one is S equals to UT plus 1/2 AT squared. The another one is V squared equals to U squared plus 2 multiplied by A multiplied by S. So this formula, they are for uniformly accelerated motion. That is a body that is moving with uniform acceleration. So because this body is moving with uniform acceleration, it means we can use one of them. And do you know which one will work for us? The second equation, of course, will work. Because if you look at the second equation, it has distance. It has this guy, initial velocity, which we have been given. They gave us distance in the question. They gave us the acceleration in the question. And yes, we are interested in the ratio of Tx to Ty. Okay. Now, in the question, do not forget the bodies cover the same distance. Okay. So let's write this equation for car X and for car Y. So for car X, the equation becomes, for car X, it will be S, the distance will be X. Let's put X there. Okay, will be equal to U, initial velocity is 0 for all of them. So if you do 0 multiplied by t, then that will be 0, of course. So you now have plus 1 half 1 over 2. So for car x, the acceleration is just a. You have a, and the time will be tx then squared. Then for car y, you have sy will be equals to u is 0 as well, 1 over 2. A acceleration for car y is 4a. So instead of a, we have 4a together, and the time will be t squared then y. Mind you, we were told that they cover the same distance, and because of that, so we can say that this is the distance for car x, this is distance for car y. So we can say that this equation is equal to this equation because they cover the same distance. Is that taken? So now, using the next slide, I can say that 1 over 2 half a t squared for x will be equals to 1 over 2 for a t squared y. Yes, because the distance is equal, and this cancel this, and a can cancel a. Yes, you can do that, and now you have t squared x to be equals to t squared y. Oh no, there is 4 here. Yes, thank you. T squared y. But we have to find the ratio of what's it gonna? The ratio of x to y. So I can divide both sides by t. We want x to be on y. So it means this time ty, I can take it to. This time ty, I can take it here, and if I do so, I can just divide. In order to do so, you can divide both sides by ty squared. Okay, make sure you revisit your algebra. Now if you do that, then you have t x squared divided by ty squared, and that will give us 4. Okay, now the next thing is, it is the ratio of tx and ty, not the ratio of tx and tx squared and ty squared. The question says the ratio of tx and ty, so that means this square must leave. So in order to do that, we can say tx over ty, yes, since both of them are squared equals to 4. So now to remove the squared, now I can take the square root of both sides. So we now have cx over cy. If I take the square root of this guy now, and I have to take the square root of this guy too to balance it. So, and for this cancels. So now the square root of 4 will be equals to 2. So that will be 2. So it means, and 2 is same thing as 2 over 1. So it means tx divided by ty, which is same thing as saying tx ratio ty is equals to 2 ratio 1. And voila, we are done. That's not right. You can go back the video, then you watch it again for better understanding. So let's move on. Okay, so look at this question. The question is on the magnetic flux in a coil having 500 turns changes at a time rate of 0.04 webers per second. What is the induced EMF in the coil? I told you the other time that whenever you see a question, try to ask yourself, where is this question coming from? This question is coming from electromagnetism. Okay, and if you look at it carefully, yes, I'll just give you the formula and I'll tell you where the formula is coming from. So if you know where the question is coming from, then easily you can get to know the formulas to apply now. So the formula we are going to use is induced EMF, or is actually equals to minus n, yes, change in magnetic flux with respect to time. So this is n is the number of turns, in the coil. So if you have a coil, so coil usually have turns. So the number of turns is n. Oh, sorry, I wrote number of coil. That's not true. It is number of turns in the coil, and this guy is a rate of change of magnetic flux. Rate of change of magnetic flux. Okay, so that's that about that. But this is the formula actually. This is the formula. This E is the induced EMF. But we are in this question, they are not even interested in, they are interested in just the magnitude. So, and I'll write the expression for the magnitude. So for the magnitude alone, this symbol indicates the magnitude. The magnitude, we are not going to include the minus. So it will just be n and the change in magnetic flux with respect to time. Okay, so now in the question, the change in magnetic flux with respect to time has been given. This is 0.04 Webers per second. So they already gave us this whole thing. Do you get that? I mean, they've given us this. So in some question, they won't give you this as a whole. They will give you the initial and final. Okay, and they will give you the time. Suppose the question says that the magnetic flux changes from 20 Webers to 80 Webers in 5 seconds. So to find the rate of change of magnetic flux, it will be 80, which is final, minus 20 divided by time. But they've done that. So they just gave us the rate of change. Please watch out for that. Okay, so they gave us the time rate of change of magnetic flux, which is Webers per seconds, and they gave us n to be 500. You can see that the answer will just be n 500 multiplied by 0.04, and that's just it. So, and that's that about that. And if you do that, that will be 500 multiplied by 0.04, and that's 20. So the option is C. So let's move on. So look at this question. The question says that a RLC circuit is used in a radio to tune into the Radio Lagos FM station broadcasting at 93.5 Hertz. The resistance is 15 ohms and the inductance is 1.6 Henry. Calculate the capacitance used. I told you it's always good to know where questions are coming from. So whenever you see something like this, we have RLC circuit. That is a circuit that contains R there stands for resistor, L inductor, C capacitor. So this is a circuit which contains resistance, inductance, and capacitance. Okay, so now in radio tuning, we use something which is resonance. Are you with me? Resonance, and that's the idea of this calculation, because at resonant frequency, okay, if you tune your radio at home, so once you tune it, once you get to the point where you feel like, oh, that is, stop there. That's when the thing becomes audible, that is the resonant frequency. Are you with me? So, and at resonant frequency, there is a formula. What happens is that capacitive reactance will be equals to inductive reactance. You may want to note that down in the sense that no one knows. They may ask you. So, at resonant frequency. So, what happens? So, another thing that happens is that capacitive reactance will be equals to inductive reactance. So if you are one of those that is thinking what is capacitive reactance, so don't think too much about that. I've told you this video is exam focused. So if you watch out on the channel, you may later find, I don't have now, for now I don't have videos where you can get to learn from the very concept what capacitive reactance is or inductive reactance. But for the sake of this, you are still cool with the fact that whenever you see a question like this, so now question that has to do with radio tuning, okay, so we use the formula for resonant frequency, okay, and the formula I will write, then we are going to do the needful. The formula is just F equals to 1 over 2 pi square root of LC. So 2 pi is just constant, L is inductance, now C is capacitance, okay, and in the question they gave us F frequency to be 93.5 hertz, and they gave us L has been given as the inductance, so L to be 1.6 Henry. So and the question says we should calculate the capacitance, so and C is the unknown, what we are trying to calculate. So now if you put everything here, you can see they give us resistance. Yes, it's funny, we don't need it actually for this question. So now you plug in everything and you have 93.5 to be equals to 1 over 2 pi square root of 1.6, which is L, then C. Then what can we do? You can cross multiply or square both sides first. Let's square both sides, and if you do that, if you take the square of this, that is this squared, you take the square of this as well, this squared, in order to eliminate the square root. And when you do that, 93.5 squared will give you, this is long, will give you 8742.5 to be equals to 1 over, so 1 squared is 1 over 2 pi squared will be 4 pi squared, multiplied by, and the square root is gone, multiplied by 1.6, then C. And if you do the needful now, then we should get, let's move on to the next slide. So we have 8742.25 to be equals to 1 over 4 pi squared now times 1.6, yes, this over. Now if you cross multiply, you would get 8, this over 1, then you cross multiply 42.25 multiplied by 4, yes, 4 pi squared times 1.6, then C equals to 1. Yeah, this is what we get, because this will be 1 times 1. And if you multiply all this times 4, you have to be good at punching calculator, things like that. Multiply by 1.6 and you get a very big number, and the number is 55228.314. You can see I didn't approximate, so that you only approximate at the final level. Okay, then you can divide both sides by this so as to get your C, and if you do that, you would get 1.81, then times 10 raised to power minus 6. What's the unit of capacitance? Farad. But in the option there is something like this here. But what is there is the 10 raised to power minus 6 is micro, 10 raised to power minus 3 milli, 10 raised to power 3 kilo, 10 raised to power 6 mega. Do you get that? So 10 raised to power 9. What's 10 raised to power 9? That should be giga, I guess. So tera, let's leave that. That's not what we are doing now. 10 to the power minus 6 is micro. Okay. Now minus 9 nano. Okay. So minus 12 pico. Okay. So minus 15 femto. But that's not what we are doing. So this is 1.8. We can say 1.8. Now 10 to the power minus 6 is micro, then farad, and that's just it. That's it. If you check the option, there's the option. So you must know, someone will get 1.8 to 1 times 10 to the power minus 6 farad, and you get to look at, my option is not there. You have to be very careful, keep your calm, and let's move on. So for this question, we have a 200-ton coil having an axial length. This is very important thing to note, of 30 millimeter and a radius of 10 millimeter. So it's pivoted in a magnetic field having a flux density of 0.8 Tesla. If the coil carries a current of 0.5 ampere, calculate the torque acting on the coil. So the idea of this question is that whenever you have a current carrying conductor, if you have a conductor, that is, if you have a piece of wire now, and if current is flowing inside a piece of wire, so if you now place the piece of wire through which current is flowing, if you place it in the presence of magnetic field, then it experiences a rotating force, and that is torque. So there is going to be a rotational effect that it will experience. It's just like, think of anything, your pen now, if it is a conductor, for instance, and there is current passing through it. So if you place it where an external magnetic field is, someone is like, what is, or where and how can I get an external magnetic field? It's very simple. If you get a bar magnet, so the bar magnet, around it there is magnetic field. Any bar magnet has magnetic field around this. So if you can get a huge, very big bar magnet now that can contain a room, so if you enter that room, there will be presence of every magnetic field. So if there is anything, a conductor which is carrying current, if it is present, then it will experience a rotating effect. It will want to turn, and that rotating effect is the torque. It's not torque. Yes, the Q is voiceless, so it's torque acting on the object. So now the current carrying, what is carrying current here is coil. The question is, if the coil carries a current, so now it is in the presence of magnetic field, external magnetic field, then it will rotate. Like, it tends to rotate. So as a result of torque that will act on it. So now there is a question for this. For torque that's acting on any object that is carrying current in the presence of an external magnetic field. Someone is thinking, how do I now, suppose I've never seen this before, how do I begin to think this way? Okay, I told you that this question, this video is, what's it called now? It is, yes, exam focus. So because of that, there are some fundamental things we may not have the chance to, explore. So, and trust me, if you can just go by what we've been doing, if I give you a question, I tell you where it's coming from, the formulas to use, and if you can just try to understand all these things without trying to cram. So if you see similar questions, then you are going to be fine. Since we are going to solve a lot of questions. Now, physics is, or part of physics is solving, or an important part of physics is, solving problems is an important part of physics. Yes, it's not how conceptual understanding is key. Okay, so now the formula for torque acting on a current carrying conductor is this. It is torque is equals to N I. So N is the number of turns, I is the current that is flowing, this is area, now B is flux density, then sine theta. Okay, but for maximum torque, so, and in this question, if they didn't mention anything about angle, so some questions they just assume maximum torque. So in this question, they already assume maximum torque, and for maximum torque, sine theta is equals to 1. So if sine theta is equals to 1, then the formula changes and becomes NIAB instead. So the first thing we need to calculate is what is our area. Now ordinarily area should have been pi r square. So if the question says a circular coil, then it should be pi r square. But since they didn't mention circular coil, for any coil with axial length, the formula is length times W, where W width will be equal to 2 times radius. Are you with me? Okay, so if it is circular coil, the formula would have been A equals to pi r squared. But because it is a coil with an axial length, then it will be length times width. But that width is 2 times radius. And now we have the length was given to be 30 millimeter. So you convert 30 millimeter to meter by dividing by 1000, and you get 0.03 multiplied by, so 10 millimeter to 1000, to meter now, that will be 0.01 multiplied by 2, then your width will be 0.02, and if you multiply them together, you have 0.03 multiplied by 0.02, and that should give you 6 times 10 raised to the power minus 4. So that if you now put it here, so this will be 6 times 10 raised to the power minus 4, and you have the number of turns to be 200. This is 0.5. This is 6 times 10 raised to the power minus 4, and this is 0.8. So if you punch your calculator, then you have times 200, 0.5, 0.8, and this gives 0.048. 0.048, and let's just move on to the next thing. In this question, we are to calculate the electric potential along x-axis. Okay, the question says the electric potential along x-axis is given by this, by V equals to AX minus BX squared, where A and B are constants. At what point on the x-axis is the electric field 0? So this question is just about relationship between electric potential and electric field. I told you when you see a question, you think, where is it coming from? So it's just relationship between electric potential and electric field. And even if you have not heard it before, I'll just tell you this relationship and you note it down. So whenever you see questions like that, you know this is the relationship that you apply. So the relationship is V, electric potential, is equals to negative dE dx. So where E is electric field, okay, and V is the electric potential. So it's electric potential. Okay, now this is the relationship. Now in the question, so the question now says that now am I making sense? Oh, sorry, I made a mistake. It is the other way around. It is the other way around. It is E that is equals to minus dV dx. Sorry for that. It's E that it is electric field that is equals to minus dV dx. Okay, so let me rub this guy off. This is not correct. Very wrong. Sorry. So EC stands for electric field. Now the next thing is to do this. To do what? Is to what I want to do. Yeah, okay, now is to, but in the question says that at what point would the electric field be 0? And this is the electric field, so we have to find the point where this guy will be 0. Okay, so when this guy is 0, the equation becomes 0 equals to minus d dx, so which is derivative. For those of you who took who did further mathematics, this d dx, or calculus, let me say, d dx means the derivative of phi with respect to x, but the v has been given in the equation as, instead of writing v, I can put ax minus bx because this is our v. Okay, and this will now be 0 equals to, so here minus, if you differentiate, you want to differentiate this guy. So if you differentiate ax, you get, with respect to x, you get a. If you differentiate, suppose you don't know calculus, let me just teach you. If you differentiate 3x with respect to x, you get 3. If you differentiate yx, no, let's say tx with respect to x, you get t. So that's just it. If you differentiate ax with respect to x, and that's what we are doing here. We are going to get a minus, if you differentiate bx squared, before we differentiate bx squared, let me tell you something else. If you differentiate 3x squared with respect to x, you get 2 times 3x squared. If you can write it down. If you differentiate 7x squared with respect to x, you get 2 times 7x, no, 2 times 7x. So for the 3x squared with respect to x, you get 2 times 3x. If you differentiate 7x cubed, x raised to the power 3, with respect to x, you get 3, that 3 will come. And now the power is 3. You get 3 times 7x now squared. It will come down. If you differentiate 7x raised to the power 5, it will be 5 times 7x raised to the power 4. So that's the logic. Now I want to differentiate bx squared. So it will just be 2 times bx raised to the power, is come down. That will be raised to the power 1. Do you get it? And try to write all this down. That will be bx. This is not calculus class, raised to the power 1. But if it's raised to the power 1, I can just say bx. Okay, so don't disturb yourself too much with the math. Just know the little that we need now, and you'll be fine. So now we have this. So we have 0 to be equals to minus a. We use minus to open the bracket. Minus times plus minus. Minus times minus plus this. And okay, so I can take a to the other side. So that will be 0 plus a. And that will give us a. And if we say 0 plus a equals to, now we have bx. So 0 plus a is a equals to bx. And if you make x the subject of formula here, your x should be equals to a over b, and the answer is b. Okay, so now moving on to the last question. So looking at this question, the question says that an inductor, okay, is capable of dissipating 50 watt of its energy when this current flows through it at a certain frequency. Calculate the impedance when the reactance of the inductor is 50 ohms. So this question, I'll just tell you where it's coming from and what to use. Whenever you have a question which involves an inductor and a resistor, you know, in this question we have an inductor and okay, a question which involves an inductor. Are you with me? Then what's it called now? In this question there is presence of resistance there. There is a resistor, and someone will ask me, how do I know there is a resistor? So you can see that in the question it was said that power of 50 watts was dissipated. So in a circuit, so what causes dissipation of power is what's called resistance. So if there is no resistance, like suppose there is no resistor that will supply resistance now or opposition to the flow of current, then the power dissipation would have been 0. So that's how I got to know that, okay, this question, there is an inductor and there is a resistor. Okay, so and whenever you have an inductor and a resistor in the equation and they ask you to calculate the impedance will be Z equals to square root of R squared plus what's this guy, plus yes, XL, and this XL is called the inductive reactance. Okay, and in the question they gave us the inductive reactance. They said when the reactance of the inductor, is inductive reactance, is 50, okay, 50 ohms. So to calculate what we have to calculate now, this is what they want us to calculate. What's it gonna impedance. We need to calculate this R. We need this R. We already know this, they gave us. Now we want to calculate this. Then we need to calculate the the resistance now. Then how do we do this? They gave us power dissipated. It's when I saw that okay, power was dissipated, I got to know that okay, there is resistance here. So, and what's the formula for power dissipation? The formula is this is power dissipation is equals to I squared multiplied by resistance. So if resistance is 0, suppose there is no resistance, the power would have been 0. So that's why I got to know there is resistance. Okay, now but the power dissipated is 50. They give us the current to be 0.8 squared, and if you do the math, you discover that this is going to give us 78. So the resistance will be 78.125 ohms. So now to calculate the impedance, that will be square root of the resistance was found to be 78.125 all squared, plus the inductive reactance is 50 squared. And if you do the math well, you should get this to be equals to coming 92.75. that will be 92.8 ohms, and the answer will be B. Okay, and this actually brings us to the end of the lesson. And if you found this lesson helpful, kindly like the video and do not forget to subscribe to the YouTube channel for more physics lesson. So the channel is actually below. You can copy this or you type it out in order to subscribe. Thank you for listening, and I look forward to seeing you around.